Hello guys, you're welcome to the Quantity Surveying Academy. It's actually been a very long time since I produced any video on this channel, and I seriously apologize for that. I've been really busy. Well, I'm glad to announce to you that I'm back on the channel once again, and I'm going to be producing your most sought after videos in the quantity surveying practice and even in the construction industry as a whole. So this video, I'm actually making this video on the request of one of our subscribers on this channel from the University of Pretoria. I seriously do not know which country this is, but I guess this should be, well, never mind. So this is the Faculty of Engineering, Built Environment and Information Technology, Department of Construction Economics. So these students told me that their exam is coming up in the month of January on the 20th of 2022. So I decided to make this video so that I could actually enlighten the students that are requesting for this, to help them understand and have a better feel of what they will be seeing in their examinations. So this is the floor plan. This is the plan that they are actually working on. As you can see, most of these things um, are written a in a foreign language. They are not actually English, so it doesn't really matter whether this is English or not, in as much as numerals, the alphanumeric sorry, the numbers are showing perfectly well. We can still work on this plan. So this is the plan, this is the floor plan, and we have other details here. This is the foundation detail for that floor plan, and then we have here the section. You can see that this we have a lintel roof here. We don't really need to work on this in this tutorial, so I'm just going to be strictly based on the substructural work and what has been prepared in the lecture note for these students. So here with me on this spreadsheet is the lecture note for the floor plan I've showed us already. So the content of this particular lecture note involves collection. Well, if you are in the quantity surveying department, there's no need to get bothered or worked up on what collection really mean. It is not actually used by quantity surveyors in our normal, let's say in our normal lessons in our classrooms. In the classroom, when you are being taught as a quantity surveyors, there is no need for anything like collection. We go straight into the taking off list that I've actually explained in my previous video. I'm going to link some of my videos on substructure in the description button, so you can click on the link you see at the right, or is it the left top corner, or you can go down to the description to click on the link that will lead you to learning about substructure. So for this student in this university, this is I guess this is their first time working on measurement, because the course is titled um I guess quantities 101. So this should be their first time working on measurement. So you have to work on collection. The essence of doing the collection, the lecturer or the course tutor actually prepared it in such a way that you carry out all the rough calculations under collections. Then you can make use of them to do the normal booking in earthwork, concrete, formwork, and reinforcement. So let us take a look at the collection. In order to do so, I'm going to split my screen into two so that we can have a proper understanding. So this is the floor plan. Let's reduce it a little. All right, so that, sorry, I'm zooming in. All right, so we have the floor plan. I'll be pivoting it this way. If you need this floor plan and also the spreadsheet, I'm going to create a link in the description where you can download it. All right, so let us take the collection. Let's start with external wall. For the external walls, we have 220 brick walls. These are the external walls in this floor plan. Permit me to zoom in so we can see the walls here from this point here down to this point, and also we have it down to this point here as well. Then you move downward to this place, you can see we have the overall length of 11,020 millimeters, while the overall width from this point to this point here is 9,860. So for this recess, we have this shorter part of the floor plan as 1,430, while this other part is 8,430. So this is what we have on the floor plan. Now in the collection, the first thing to do is to pick out the total guards for the external wall. You can go down to my video and watch my video on mean guards, which I've explained how to calculate the mean guard of a building. But for the students of this university and also the students that are taking this course in their various classrooms, I would advise that you stick with the model or the pattern of which your course tutor, your course advisor, your lecturer is taking this course. So in this case, instead of taking our normal traditional way of calculating the mean guard that I've taught so far so good in this channel, we will just work on what we have on this spreadsheet. So for the 220 brick walls, we all know that we are expected to pick this length from this point down to this point here, which is 8,430. So this is it. We have it as 8,430. We have it in the spreadsheet as 8,430. So we are going to deduct. If you notice, dimension is out to out. So we are going to deduct this block thickness at this point and at this point. Since the block is 220 thick, we'll be deducting two of it. That is one here, then okay, one here and one here. That is two. So that's why we have 8,430 minus 2 by 220. So the final answer we had for that is 7,990. So we are done with this first part. Then we will now move over to this shorter part. So for the shorter part here, if you notice, there is no instance, or there is nothing that shows that there is a wall here. But when I went through the spreadsheet, I realized that there are some places where the dimensions were taken as if there is a wall along this horizontal plane. So that is not a challenge. I just need to explain what was done here. So we have this dimension from here to here as 1,430. So normally if you are excavating, there's always a spread that shows up here. So I've explained the concept of spread already. I'm still going to link a video that you can see above. You go and watch and understand the concept of spread. I don't want to drag these videos too long. That is why I would be linking that video that I've spoken about how to calculate this excavation, including the spread. So when we are getting the length for this, we're going to pick 1,430. That is from this point to this point. Since there is a spread around this place, because if you carry out an excavation along this horizontal length, there will be a spread extending upward this way. So we have minus 220, which is for the spread. Since there will be an additional spread here, and after this wall here, we are going to also add 220 at the top here. So here we are minusing 220 for the spread. Here we are adding 220 because the spread above here will be added to this length, while the spread here will be deducted from this length. So minus 220 plus 220 would cancel out each other, and we'll be left with just 1,430, exactly the figure we had here. So after that, we'll move over to the length, which is 9,860. So this is it. Take a look at it from here. We have 9,860. That is the overall length from this part down to this place, 9,860. So as we did initially, we're also going to deduct twice the block wall, which is 230 above here and 230 below here. So that is what was done here. 9,860 minus 2 by 220, which would give us 9,420. So if you look above, after transferring all these figures, 7,990 to this place, that is 7.99, 1.43, 94.42. We have this value which we did not show up here, 11.02. And this is where we got it from. This overall dimension at the bottom, 11.02. So we are going to pick 11.02 from this point to the ending point. So when we have 11.02, multiply it by 2 because it's going to be above and below. So just above and below, we have it as 11.02, and that is why we multiplied it by 2, because we have the overall length above and the overall length below. Okay, so having known that our overall length, mind you, forget about the fact that this place has a recess. The length from here to here plus the length from this point to this other point will give us the overall length that we have below as 1120. So the bottom and the top will all be 11.02. That is what we have here. So these are the four dimensions. When you sum them up together, 2 multiplied by 11.02 plus 7.99 plus 1.43 plus 9.42 would all give you 40.88. Now this figure that we have here is what we are going to use when we start booking our dimension after doing this collection. So like I said earlier, the collection is meant for us to be able to calculate and bring out all the figures we'll be making use of in the taking of. This is how the coursework was arranged. So if I'll be measuring my 220 brick wall in foundation, the length of the brick wall is going to be 40.88. That is the length around the external walls, you know. But remember that block work is always measured in meter square. So it is measured in meter square. But since this is a collection, I'm not booking the measurement or the dimensions of block work yet. I'm just picking out the length that I know I would later book in my block work. So the block work will be 40.88 when I'm booking for block work. But if I'm booking for my concrete in foundation, well, I'm still going to repeat the same thing. It's still going to be 40.88, which is still the same length around the external surface. Yeah. So we have it as 40.88. So the perimeter length around the external block work, 40.88. That's where we're going to pour in concrete. This 8 by 0.27 is not actually necessary. What was done here was addition of some corners, which in my own opinion, since you've gotten the mean guard, you don't need to bring this out. Moreover, if you notice, the 8.02 here cancelled out this 8.02. This 8 by 0.27, sorry, 0.27 here is gotten by calculating the spread. And in order to calculate the spread, you just need your foundation detail, 750 by 250. So when you pick the length of your foundation, which is 750, you're going to deduct the block thickness. So the length from this point here to this point here is 750. So I'm going to deduct this block thickness of 220. Any value I have, I'll divide it by 2 to get the spread from this point to this point, and also from this point to this point. So as you can see, we have 750 minus the block thickness, which is 220. So the final answer, the answer we got is 530. If I divide it by 2, I'll end up getting 265. If I want to transfer it to this place in 2 meters, in 2 decimal place, I'll end up getting 0.27. So 8 by 0.27 is simply the spread that is gotten around all these dimensions. You see, we have one corner, we have another corner here, we have these 3, then we have 4, 5, 6, and where again, well, okay, I think we have 7, then we have 8. So these are all the T-junctions that are attached to the external block wall. That is why I say they are not necessary. So it's not necessary to bring in this figure and this figure here, because at the end of the day, you are still going to be making use of 40.88 to carry out your concrete in foundation calculation. So that is the length you are still going to work with. So take note that this is not necessary, but for the purpose of exam and as students, you can just bring this in. That is, if you are a student of this university, make sure you remember to bring this in and also write out the deduct as well. But remember that 8 by 0.27 is going to cancel out this other 8 by 0.27. So that is that for the external wall. So for the internal wall, if you look at it carefully, we have the brick 220 brick wall internally. So take a look at this. If you look at this plan, we have this internal wall here from this point here down to this point. So this is an internal wall. If you want to check out the dimension for this internal wall, you would discover that what we have is 8,430. That is from the beginning here, out to out, 8,430. But if I decide to subtract this internal block and this external block here, sorry, the two external blocks we have here, then we are going to arrive at 7.99, which we have done before now. Look at this. You see, we have 8,430 minus 2 by 220. It still gives us 7,990. So that was what we've done before. So we have 7.99. Then the second 220 brick wall we have in this plan here is giving us 370, sorry, 3,730, as you can see. And this is the internal block wall here, which is 220 thick. There, here it is indicated in the dimension. From this point to this point, in to in, is giving us 3,730. That is why we have 3.73 in this case. So remember that the internal wall, the longest internal wall, 7.99, then the shortest is 3.73. And these are the, so if I sum up these two values together, I will have 11.72, which are the values I'll be using for my booking, both for excavation and also brick wall in foundation. That is why we have it as 11.72. So don't forget, this is the length we are going to be using when we are carrying out our booking after we are done with this collection. So if we are now working on concrete in strip foundation, please, this is block wall. The dimension, you take dimension as it is from this point to this point in block wall. But I've explained in my video, in my subsequent video, sorry, in my previous videos, that when you are carrying out concrete in foundation and also excavation, the gut you are going to use is different from the gut you'll be using when you are working with block wall. So for the block wall, we are using this 11.72 automatically. But for concrete work, we are going to deduct the spread here and the spread here. So we are going to deduct another spread at this point and another spread at this point, making it two spread along this longer wall and two spread along the shorter wall. That is the reason why we are having deduct 2 by 2, because we have two spread along the longer wall and two spread along the shorter wall, and we are multiplying it by the spread which I have calculated earlier by subtracting 220 from the foundation width, which is 750, divided by 2. So we got our spread to be 265. So that is why I have it at 0.27. So we have 2 by 2 by 0.27. So that is the spread for that we're going to be deducting from this overall, this length here, this internal length for 220 block. I know you are wondering, what about this wall here? We don't really need this wall right away. This wall is 110 It's different from 220. So our overall length we now have is 10.64 for the internal wall of 220 thick when we are measuring for concrete. Then we'll now move down. We are still in our collection. This is for 110 brick wall, and the length of 110 brick wall is the same as the length we have for this 220 at this shorter part. So from this point to this point is giving us 3,730. So that is why the length for this 110 brick wall is still 3.73. But the block wall in foundation, this is going to only affect the superstructure. But in the foundation, remember that the block wall are usually the same throughout. Look at the details. Even if you look down into the section, you will discover that all the block wall, even when you have the 150 and 110 brick wall here, in the foundation it is still given as 220. So the brick wall in foundation will still maintain 220 brick wall in foundation. So it's still going to be 3.73 as given in the dimension. From this point to this point, 3.73. Then when we now get to the concrete now, the concrete, we are expected to deduct the spread at this junction and at this junction. So that is why we just have 2 by 0.27, because we have only two spread here, unlike the other one, the other internal wall, which we had to deduct 2 by 2 because of two different internal walls. So here we have just two spread from this point and at this point as well. That is why we are deducting 2 by 0.27 for the spread, giving us 3.19. So that is that for the internal block wall. So now we are done with the collection. We are now moving down to the taking off or the measurement proper. So what we have here is foundations provisional, and here is our measurement list. We have earthworks, so we have site clearance, excavation for trenches, hard and soft rock, risks of collapse, backfilling in trenches, keeping excavations free from water, soil poisoning in trenches, cutting away slash cutting on. Then we have concrete, formwork, and reinforcement, which is going to, and the foundation type is concrete in strip foundation. So the taking off list are actually little compared to what I've been teaching on this channel before. The truth of the matter is, because these students or those of you studying this particular course, you're not actually quantity surveyors. You're studying something that is relating to the quantity surveying field. That is the essence why the taking off procedure is not taken in depth. Otherwise, we would have had more items on this taking off list. But since these are the only taking off lists that are treated in class, I'm just going to go through this taking off list with you on this in this video as fast as I can, so that you can have a perfect understanding, or you can have an insight into what the taking off and the measurement process is. So for this particular takeoff list, what we have first is the site clearance. So I'll move down. This is our site clearance. Now we have the length of 11.02, which is this length here that we can see on the floor plan, 11.02, and the 11.02 commences from this point and ends at this point here. But what you need to bear in mind is that when you are carrying out site clearance, you need to add some let me say some working space. You need to add just, yeah, you need to add an additional space so that you can actually have a clearer space to carry out the work that is to be done. So in this case, the assumption that is made is that the working space or the spread that is added to the topsoil excavation is 1,500. So the estimator, or the taker, the person that is taking off, that has prepared this material, made an assumption of 1,500 to be the working space that will be added by the side of this structure, sorry, at each side of the length and width of this structure. So at this point, you'll be adding a working space of 1,500. At this other point as well, you'll be adding a working space, or yeah, or an additional space of 1,500 to take care of your topsoil excavation. So we have 11,020, add twice, that is here and here, working space, which is 2 by 1,500. We now have it as 14,020. Then along this place here, along this shorter width, from this point down to this top here, sorry, let me, oh, sorry about that. Okay, from this point here down to this point, we have 8,430. So this is 8,430 from this point to this point. So we are also expected to add working space 1,515 at this place, which is going to give us 11,430. So 8,430 plus twice working space is this value we have here. Then for this other place here, from this point to this point, we have it as 1,430. Okay, no, not there, sorry. This is going to remain the same. This is going to remain the same because the 1,005 that has been added already to this 8,430 will take care of the additional space for this place here. So we'll just move down to the last part, which is the width from this point to this point, and the width is given in dimension as 3,730. So since we have 3,730 and this dimension is in to in, so we have to take it out to out before we add our adjustment, that is working space. So dimension of 3,730 is given from this point to this point, so we need to add this wall thickness and this other wall thickness to make it out to out. That is the reason why we have 220 here for this first wall thickness, plus this in to in dimension from here to this place, which is 3,730, then plus this wall thickness again of 220. So we now add our spread 2 by 1,500. So we are going to have 1,500 at this place and another 1.5 at this place. So that is going to give us 7,170. I know somebody is asking, why are we not adding this working space at this place where we have 1,430? Just bear in mind that since we've already added it to the length of 8,430, there is no need of adding it here again. If I go further in my explanation, I may likely take up too much of our time. So just bear in mind that whenever you have this kind of a structure and there is let me say a projection this way, if you've added the space, the working space, to this first length along this particular dimension, that is along this vertical space, then you don't have to add it along this vertical anymore, because they are the one that is added to this first one has taken care of the additional space for the rest of them. So in our booking, since we are now carrying out the measurement and this is no longer collection, we are going to book. So we have the first value 14,020, which is the length from this point here to this point, by this the width from here to here. And what we have as a width along this 8,430 side is 11,430. That is why we have 14.02 by 11.43. That is these two. Then for the second booking, what we've booked has already covered for this entire area, remaining for this entire area here. So it is going to be remaining this small area from here to here and from here to here. So we are going to make use of the length we got from this point to this point after adding working space of 7,170, which we have it as 7.17, by the width, which is 1,430. So we have it as by 1.43. So that is what we have for our what do you call it, for our topsoil excavation. So all you need to do is to multiply these two values, 14,000 by 11,000. Any answer you have, you can put it down here. Multiply these two, put it down here as well. Sum them up together, you are going to have this 170.50 meters square. So that is the area for or the quantity in area for the topsoil excavation. Having done this, we will now move down to the next one. Please mind you, these values you have here are an alternative to what we have done, so you can follow this procedure or you can do what we have done already if you understand it clearly. So you move down to the next procedure. In the next procedure, we are working with okay, we are carrying out excavation, and remember, excavation is measured in meters cube. That is trench excavation. Aside from topsoil excavation, which is measured in meters square, other excavations are usually measured in meters cube. So we have excavate in earth not exceeding 2 meters deep below natural ground level for trenches. Now remember, in our first calculation in the collection, we had our GAT. The first mean GAT we got was 40.88. That is what we have here for the external wall. So the external wall, the GAT for this external wall, which is 40.88, will bring it down 0.75, which is the width of our foundation as stated before, 750. So 0.75 here is the width of our excavation. Then this last value is 0.80. So the calculation here is that we are going to the footing is 250, and let's go down to this place. So although I can't see anywhere that this is stated in the section, but let us just make an assumption and agree that the footing is 250 mm from this point to this point. That is 250 mm thick, while the distance from this point to the level, that is the level below ground level, is 550. So if you sum them up together, you have 800, which is the depth of our excavation. So this first one is the mean gap we've calculated in the collection. The second one is the width, and this third one is the depth of the excavation. So this is for the external excavation. Then for the internal excavation, remember that we got 10.64 for the 230 wall. That is these two walls here, this internal wall here and this other internal wall here. So we had 10.64. If you go back to the collection, I think number 6, you would realize what we have. So let me scroll up so that we can take a look at this in the collection. So you can see it in number 6, 10.64. That is what we picked. So take note of that. Okay. So like I said, this is for the external. Remember, the width are the same, the depth are all the same. All that changes is the length that we have already calculated in the collection. So this is the external. This is the 220 block in the internal part of the building. Then this last one is the calculation we did in the sorry, for the 110 block wall in the building. So this is for the internal block wall, 3.19 internal block up, which is 110 here is this in the plan. So 0.75, which is the width, 0.80, still the same thing. Remember that I mentioned that the dimension for the work underground, that is in substructure, are the same throughout, irrespective of the block thickness. The block thickness become relevant when you move down to the superstructure, don't forget. So we have our handing on extra over excavation in earth for trenches and holes for excavation in soft rock. So 10%, this is just an assumption. So the assumption is that the quantity of sorry, the additional excavation that is supposed to be done in the trench and the holes that are supposed to be done to be able to extract rocks that can be found underneath the ground while carrying out this major excavation is 10% of the original excavation. So 10% of this original excavation will give us 3.28 meters cube. So why for hard rock, this one is for soft rock. So for hard rock, we are expected to give um, a 5% allowance for hard rock. So 5% of the original trench excavation quantities. You know how I got this 32.83 is by summing up, multiplying 3.19 by, in fact, squaring this. Any value you have, you drop it here. Then we square this other one, this multiply by this times this. You write the answer you have here. Then the first one too, you do the same. 40 times 0.75 times 0.80. You write the answer here. So this figure plus this figure plus this figure should give you 32.83. Then you can now look for the percentage of soft rock, 10%, you write it down here. 5% for hard rock, you put it down here. So that is what we have there. Then last thing is earth filling obtained from the excavations in backfilling to trenches, holes, etc., compacted to 93% of this. So this is like backfilling. I've explained the concept of backfilling in the videos I've linked before now. So I'll still put it down. If you want to learn more about backfilling, I'm going to indicate it in the description. You can go down and click on it, watch that video, and I believe you will have a perfect understanding of what backfilling is. So with that, you are done with this. You are done with the excavation as a whole. So this brings the end to the trench excavation and also excavation of rocks, both hard and soft rock, in this particular plan. So we now have keeping excavations free from water according to the standard method of measurement, or even if you're using the BSMM or the NRM2, you discover that you would have to exclude water in some scenario when you've carried out excavation. So it is always measured as item. So just write down item in case you're writing your examination, and that is okay. So we'll move down to the next one, which is the risks of collapse. Okay, risks of collapse of sides of trench and hole excavation not exceeding 1.5 meters deep. Now, this entire description here is talking about earthwork support. I believe I've explained earthwork support in my videos before now. So if you've watched my part one of the taking off quantities for substructural work, you realize, or you'll be able to see the earthwork support calculation that I've explained. So the earthwork support is calculated by bringing in your mean girth multiplied by the depth of your excavation. That is all you need for your earthwork support. Mean girth multiplied by depth. It is always 2. So this is a diagram here. You put the wood at this side and you put it at the second side of the trench. The same thing applies to this side. So you put the wood at this side of the trench and you put it at this other side that is not showing of the trench. So the wood are supported by bracings. I didn't have enough time because I've been busy with exams, so I was unable to produce more illustration. I promise to be more let me say well explanatory with illustrations in my subsequent videos when I'm done with my examination. But because this is an urgent video, that is why I just made only this illustration. So you would have the wood at this side of the trench and at the second side. The same thing here, you have the wood here and here. That is the reason why we are having those by 2 in this case. So 2 by 40, this 40.88 is the trench of the external wall, and 0.80 is the depth of the trench as earlier stated. So multiply by 2 because we are going to have the and what do you call it, the earthwork support at this side and at the other side to prevent the excavated material, the wall of the excavation from falling into the excavation. Then 10.64, we already know that this is the value of this wall plus this other wall that we've calculated in the collection by the depth 0.80, then multiply by 2 because of the two sides of the trench excavation, of the earthwork support. Then this is for this 110 wall, 3.19 by the depth by 2. So if you have done this, you transfer your values to this place as I've always explained. Then we are going to deduct. Now take a look at this. Take a look at this particular drawing. You would realize that when you put the what do you call it, when you put the earthwork support from the beginning of this trench down to this ending here, and you decide to do the same from this point to this point, there will be no need for you to put a wood from this point to this point. So there is always no need to put a wood when you have an intersection between two walls. So look at this wall or this trench intercepting with this other trench. In this area or in this section, the wood will be placed, or the earthwork support will be placed from here to this place. But along this second part of the wall, you will realize that when you place the earthwork support from here, you will stop here. Then you will now start over from this place and continue down to this place. So this opening here, this point of intersection, does not need a wood because the wood or the earthwork support will not do anything here. So we need to deduct this space here in each of the intersection on the plan. So take a look at it. The dimension is the distance from here to here, which is the entire width of the excavation, and then the distance from the top to the bottom, that is the depth of the excavation. So remember, if we are dealing with our earthwork support, we are going to subtract the distance from this point to this point and then the depth. So let us go back to this. If you look at it carefully, you can see 0.75 by 0.80. 0.75 is the distance from here to here, because this is the overall width of the excavation. The overall width including the spread, which is 750. From this point to this point is 750. Then from this point moving inward, that is downward, is 800, which is the depth of the trench. So that is why I did this illustration to explain this. Look at it carefully and let us count together. Now we are deducting 6 of these. Let us see whether it is 6. There is a T-junction here. That is, there's an intersection between this wall and this wall here. So we have 1, 2, 3, 4, 5, 6. These are the only point of intersection we have on this plan. That is why we have 6 here. And 0.75 is the overall width of your trench, and then 0.80 is the depth of your trench. So that is the essence why we had this deduction. So we call those parts, this point of intersection, the T's. You can see we have a T formed around here. We have another T formed around here. A T here, that is 3. The fourth T, fifth T, and then if you move upward, we have the sixth T. It doesn't really complete as a T, but it is actually a T. So that is why we did this deduction in this place here. So moving downward, we're almost done with this, so stick with me to the end. And please, if you like what I'm doing on this channel, make sure you subscribe to this channel, click on the notification button to get notified of our subsequent videos, and make sure you inform your friends, inform your classmates, tell them to come and check out the Quantity Surveying Academy to acquire more knowledge in construction and also in the profession of quantity surveying and civil engineering works. So let us round this up as fast as possible. For anti-termite treatment, which is anti-termite poisoning to bottom and side of the trench, we need to get the gut of the trench. So to get the gut of the trench, we are going to pick up, look at this, we are going to pick up the width, that is the bottom. We are looking at the bottom here, the width of the bottom, then the height or the depth of this one side plus the depth of the second side. That is how we get the gut of the trench for only termite treatment. Remember, it's only for anti-termite treatment. The width plus the depth of one side plus the depth of the second side will give you the gut for anti-termite treatments. And that is what we have done here. So let us take a look at it and round up this tutorial. Okay, so to bring this tutorial to the final phase of itself, 800 is the depth of one side, 750 is the width of the bottom, which we may not likely see on this place, but we can see it in this page here. 800 is the depth of this side, 750 is the bottom that you cannot see from this diagram, then the other 800 is the depth of the second side. So that's what you are going to do in this anti-termite poisoning or the termite poisoning. Yes, so it's 800 one side depth plus 750 the bottom plus 800 the depth of the second side, giving us 2350. So if we are booking, just like in earthwork support, we are going to do something similar here. We'll book the mean guard 40.88 by this yes, the mean guard for external by the guard for the side and bottom of the trench, which is 2.35. Then we are still going to book the mean guard, this internal mean guard, that is for this wall plus this wall, which we have it as 10.64 by the guard that I got for the width and side, sorry, the width and depth of the trench. Then this last one is for this 110, this last wall here. So we have it as 3.19 by 2.35, which we've calculated here earlier. So let us take a look at the deduction, the same thing, because anywhere, any space you are going to be having this opening, there will be no point of pouring any anti-termite treatment on it, so we have to deduct it. So look at the deduction. We are repeating the same deduction that we did in topsoil, sorry, in the earthwork support. So it's still going to be 0.75 by 0.80, then multiply by the number of T junction, which are 6 in numbers, I've explained earlier. So you repeat the same thing here, the same way you deducted. That's how you deduct it here. Look at it. If you are pouring all the anti-termite treatment around the body, this space that is open, you cannot pour anti-termite treatment in it. That is why we are picking the length from here to here by the depth. So that is what we have in this case. So I hope you're understanding. If you're understanding, just smash the like button so that YouTube can continue to recommend my videos to other students and other professionals that really need this knowledge as much as possible. So for the final phase, what we have here is the unreinforced concrete 5 megapascal or what have you in strip footings. So we have unreinforced concrete 5 megapascal in strip footings and deduct backfilling in trenches as before described. I've explained this concept before. So what you just do is you're booking. This is concrete in foundation. So you're going to book a mean guard by the width of the excavation, which is 0.75. Then by the thickness of your concrete, come down to this section. You will see that the thickness of the, if this is the width 750, then this is the thickness 250. So it's going to be in concrete. If you are booking for concrete, it's going to be the mean guard by the width of the excavation or the width of the trench by the thickness of the concrete 0.25. So we'll go down to the second one, which is the internal 220 wall. So we have the guards for those two walls, that is this wall and this wall. Then we also have the width 750, that is 0.75. Then the thickness of the concrete is the same throughout, 0.25. You do the same for the third value here, 3.19, 0.75, 0.25. Then you get the total you need in this place. Then you move downward, and what we have here is earth filling supplied by the contractor. So this allow means we are going to be allocating a prime cost to these items. So that means you are going to dedicate a specific amount of money that will be used to purchase earth that the contractor will supply to the site to carry out filling. So you just need to get conversant with this description here. Is an allowance, so it is a PC sum. So earth filling supplied by the contractor. It says note, allowance to be made until such time as the measurer is in a position to determine whether this item is required or not. Then we now have extra over all excavations for the cutting away of surplus excavated earth to a dumping site to be located by the contractor. So this is total of all excavation. So since there's no excavation that is being retained on site, the total of all excavation you have is what to be booking down here. So you go back to what we've done already and check for where you have excavation, and then you book it down here. So deduct total of all fillings. So anything you have for total fillings that have been measured, you put it down here as well. That is what this is all about. So when you have done total excavation, you are going to deduct the total filling, and you can read this other note on your own after now. So I hope this video helps. I actually did this. I had to rush this because I'm also in my exam week and I've not had time to make more videos. Like I said, I'm going to be making a lot of videos immediately after my exams, and at least I'll be able to have enough time to work something out before I can continue my final year project as it comes at me. So thank you for sticking to the end of this video. I hope this helps you a lot. Make sure you subscribe to this channel if you are yet to subscribe, and like this video. Click on the notification button to get notified of subsequent videos. Share it with your friends, your classmates, your colleagues, and other people that you may think are interested in seeing things that can enlighten them about construction, estimation, and the quantity surveying practice, as well as civil engineering work as a whole. Thank you for your time and have